everyone. Today we're going to continue on our topic of factoring. Last we talked about just factoring out a greatest common factor, or a GCF, out of many terms. Today we're going to talk about how to use that same idea of taking out GCF in order to factor by grouping. So we're still dealing with polynomials, or many terms, many monomials added or subtracted together. But now you're going to be using the distributive property multiple times to factor polynomials with 4 or more terms. Whenever you see 4 or more terms, you're going to use this factor by grouping method. Let's take a look at a couple examples together, and then I have some for you to try on your own. So what you want to look for when you see that there are 4 or more terms is any terms that have common factors. So I noticed that in this polynomial, I see that the 4QR and the 8R, they would have a common factor of 4R. But I also noticed that 4QR and 3Q have a common factor of Q. I'm looking for what has the most in common. So I'm going to go ahead and group up these two terms because they would have a greatest common factor of 4R. And I'm going to go ahead and group up these two terms because they would have a greatest common factor of 3. You might not always get it correct on your first guess, but we'll go ahead and try it. To group them together, you'll use parentheses as your grouping symbol. I like to use colors with this, so I make one group one color, the other group a different color. In each group, take out the greatest common factor just like we did in the last lesson. So in the first group, my greatest common factor, like I said, was going to be 4R. When I distribute out the 4R, when I undo that distribution, it leaves me with Q plus 2. I know that that's going to be a Q plus 2 because if I distribute that, it would give me 4QR. And to the second term would give me 8R, so I know I did this right so far. Then I'm going to bring down my plus sign, and now I look at my second group. For 3Q and 6, it has a common factor of 3. When I factor out the greatest common factor of 3, it leaves me with Q plus 2. I know that's correct because that would give me 3Q plus 6. So I'm on the right track so far. Everything's equal to the line above it. Remember, everything always has to be equal to the previous line. Nothing can just disappear or change suddenly. Once you factor out the greatest common factor of each group, the two groups should now share a common factor. If this can factor, what's left in your parentheses should be the same. So what you're going to do is you're going to treat the Q plus 2 as the greatest common factor between the two groups, because the green group and the pink group, they both have Q plus 2 as a factor. So that means the green group and the pink group have that in common. We know that when two terms have a factor in common, we can take it out. So what we're going to do is we're going to factor out the Q plus 2, and you'll look at each group. When you factor Q plus 2 out of the first group, it leaves you with 4R. When you factor Q plus 2 out of the second group, it leaves you with a plus 3. So essentially, this was our GCF. It was multiplied by 4R in the first group, and it was multiplied by a positive 3 in our second group. Now you take a look, can 4R and 3 be factored anymore? No, so you know that you are finished. In order to check your work, it's going to look the exact same as what you did on the last lesson, where you just distribute this back out. So this time, we'll start by distributing Q. Q times 4R makes 4QR. Q times 3 makes 3Q. Then you distribute your 2. 2 times 4R makes 8R. And 2 times 3 makes 6. None of those terms are like terms, none of them combine. But when we look at our question, yes, the terms are out of order, but we know the order of adding and subtracting doesn't really matter. So this matches the question, so we know we got it right. Once you check your work, now you say your final answer is the factored out version, q plus 2 times 4r plus 3. Remember, factor means figure out what's multiplied together to give me this answer. So you're just undistributing everything to get your answer. Let's try another one together. This one also has 4 or more terms. Let's take a look and see if we can find any terms with like factors. So when I take a look at the first two terms next to each other, 2 and 15 don't have any other common factor other than a 1. So I'm actually going to look for a different term to group up with my 2u squared v. I am going to look at the next term down in the line is negative 6u squared. I think that might be a good option because I see these two terms both share a u squared, and they would also both have a common factor of 2. So I'm going to make this my first group. 2u squared v minus 6u squared. Then in my other group, I'm going to make it negative 15 and positive 5v. This is an important one for you to notice this on. You might have noticed in the last one that I had a plus sign splitting up my two groups. No matter what, you always want a plus sign between your two groups. So in step 1, when you go to make your two groups, there should always be a plus sign in between. So step 1 is group them up. Step 2, we look at each group. If you want to color code these again, you can. What's the greatest common factor of each group? Factor it out. The first group has a greatest common factor of 2u squared, which leaves us with v minus 3. The second group has a greatest common factor of 5, so I'll pull out the 5 and I get negative 3 plus v. Now I look at my two groups. Do these two groups have the same common factor? V minus 3 and negative 3 plus v. Are those the same thing? Yes, because in both of them, the v is positive, the 3 is negative. If you need to rearrange it to see it, negative 3 plus v is the exact same thing as v minus 3. If you'd rather write a new line and write that down as a separate step, you can. So that you can really totally see v minus 3 is a shared common factor between the two groups. Once you find that the two groups have a greatest common factor, you pull it out. So now we take out the v minus 3 from both groups. When you take out v minus 3 from the first group, you're left with the factor 2u squared. When you take the factor v minus 3 out of the second group, you're left with a positive 5. So to repeat, the GCF comes out, and it comes from being multiplied by 2u squared in the first group, positive 5 in the second group. Again, to check your work, you re-multiply them together. So now you're going to go v minus 3 times 2u squared plus 5. Distribute the v first. You get 2u squared v plus 5v. Now distribute your negative 3. You get negative 6u squared minus 15. Double check. Does that match your question? The first term is the first term the same. The second term I have here is a positive 5v, but I see that here. Next I see negative 6u squared, which is the third term in the question. And then the last term in my checking was negative 15, but I see that as the second term in the question, so I know it all matches and I got it correct. Once you check your answer, now you write your final answer is v minus 3 times 2u squared plus 5. Always double check, does that 2u squared plus 5 factor anymore? No, so you know that you're finished. Okay, so those are the two practice problems I wanted to start with. Now, before you move on to do some practice problems on your own, I want to go through the 3 steps that we've been doing. Step 1, we've been grouping up the 2 terms into 2 groups by looking for what seems like they go together. We are putting a parentheses around them and a plus sign between the 2 groups. Then we look at the 2 groups, we take the greatest common factor, or the GCF, out of each group. After we took the GCF out of each group, in step 3, there should be a matching factor in those 2 groups. Like on example B, it was v minus 3 was matching between the 2 groups. So we factored out the matching factor, and then we checked our final answer. So see if you can follow those 3 steps and do the problems on the next page. Here are the correct answers for the practice problems here. Take a look at them, pause it if you need to, write down any questions that you might have. And now we're going to finish up with one last problem where we might not always get exactly what we want when we factor it out. Let me show you what I mean by that. So when I take a look at this problem, I am following the same 3 steps. So I'm going to factor this by putting 2mk minus 12m in one group, and I'm going to put 42 minus 7k in the other group. Step 2, factor the greatest common factor out of each group. The first group has a common factor of 2m. That leaves me with k minus 6. And my second group has a greatest common factor of 7, which leaves me with 6 minus k. This is looking similar to the problem B that I did earlier today, where I had 2 parentheses that looked similar, but they weren't exactly the same because they were flipped around. However, this one is not the same, because notice in the first parentheses I have positive k, in the second parentheses I have negative k. In the first parentheses I have negative 6, in the second parentheses I have positive 6. So when that happens, if you have exact opposite terms in the factor, what you're going to do is, instead of factoring out a positive 7, you're going to redo this and factor out a negative 7. So that's okay if you don't get it right the first time. Sometimes even I still have to redo this occasionally. Instead of factoring out a positive 7, I'm going to take out a negative 7. So if you want, you can put plus negative 7, or you can just put minus 7. When I redo this and I factor out a negative 7 from 42 minus 7k, that would get me a negative 6 plus k, because negative times a negative will make that positive, and then a negative times a positive will make that negative. Now my 2 factors are actually matching. They both have positive k, they both have negative 6. So since the 2 groups have a matching factor, I can pull it out as the GCF. My GCF between the 2 groups is k minus 6, or negative 6 plus k. It doesn't matter which order you put that in. I'm going to put k minus 6 for standard form. And when I factor out that k minus 6, the GCF, I'm left with 2m from the first group and negative 7 in the second group. Because if I were to distribute that, I would have k minus 6 times 2m plus k minus 6 times negative 7. So again, to repeat, the 2m is coming from the first group, the negative 7 is coming from the second group, the k minus 6 is the GCF between the 2 groups. Just like before, you can check your answer by distributing it back out. So let's take a look at this. If I want to check k minus 6 times 2m minus 7, I'm going to distribute the k first. I get 2km minus 7k. Then I'll distribute my 6, my negative 6 actually. I get negative 12m positive 42. Double check, do all four of those terms match what I have up here? Yes, so I know I got it right. Once you check your answer, now you can write down my final answer is the factored out version, so k minus 6 times 2m minus 7. All right, there's one last problem for you to try where you're going to have to use this technique of factoring out the negative instead of the positive, but go ahead and see what happens on that one, and when you're ready, you can check your answer. I hope you guys learned a lot today. We're going to continue factoring with the same method tomorrow, but we're going to add one step in the front, so be ready for that. Make sure you understand how to factor by grouping. Talk to you soon. Bye.